Okay, so here we go. Let's go on to session 2. Just as before, the username is ALG1. The password is teach, TEACH, 2025. If for some reason the reason doesn't log in the first time you click it, if it says error, close that tab, go back to it through the link of the Google Classroom, and then try again. But it's ALG1 teach 2025.
Were there about to be a bunch of technical questions on this?
Possibly.
A what?
A bunch of different types of typing questions. All right, so for session 2, let's continue. We're going to choose session 2, which is also with a calculator. Arrow through all of these things until you get to question 15. Here's where it starts getting a lot easier because we do get to use Desmos. It says a system of equation is shown. What is the x value of the solution to the system? Enter your answer in the box. So remember to keep this on your screen. I'm coming to check it. But what you're going to do is enter in the system 2x plus 2y equals 17. That's your first equation. Second equation is 4x minus y equals 25. Where is the solution to a system like this? What am I looking for on the graph? Where what? When the lines intersect. Be careful about reading what the question itself asks. The question only wants us to put the x value of the solution. So I'm only going to put the 6.7 in this box. Leave this on your screen as I come around to check, please. Good. Good. All right. Let's arrow to question. Make sure you write that on your paper as well. Let's arrow to question 16. 16 is going to require a little work, so I'm going to go back to the flip chart so that it can record those steps. But for 16 right here, go back. All right, 16. You ever notice that once you get the graphing when you take the notes calculator session, it's like, oh my God, I want a calculator. And then when you get the calculator, it's like, I really don't need it as much. Yeah. So it's still going to be like that. So this one doesn't actually give us the function equation. It just shows us a graph. And it's saying a quadratic function is graphed here. In which quadrant would the vertex be if we made these shifts to it? So I'm going to remind you about the shifts of parabola. The vertex form of a parabola, remember, was x minus h squared plus the k. Remember what the h did. H moves it side to side. Since what's inside these parentheses has a minus sign, it's the opposite direction of that sign. So a minus is actually going to go to the right and a plus to the left. The K value, what?
You put it right on the left side. Like, they're on the wrong side. Really? Uh-oh. I'm confused.
Okay, so when I have this minus h, it moves it to the left. Like if I just have, the minus sign is part of the formula. So if it goes to the left, it's a plus. Plus goes to the left. and minus goes to the right. There we go. The K is moving it up and down. Positive goes up, negative goes down. So whenever I'm going to be moving, see how it has an X plus 3 in here? That means it's going to go to the left, 1, 2, 3. And then this plus 2 on the outside moves the vertex up, 1, 2. Here is where the new vertex of my parabola would be. So in that test itself, all you're doing is selecting by clicking on the correct quadrant that it's now in, which is quadrant 2.
Oh, that's easy.
Yes, it is. So click on quadrant 2. Make sure you have that written. Did everyone write that, or you need more time?
No.
Okay. Let's go to question 17. Again, 17, we don't need the graphing calculator because it's something we have to work out and write. 17, and we've done, y'all, I know we've done this one many times. Number 17 says, here's the formula for the perimeter. Which formula shows the same formula, how to find the length, so we're solving for L if we know the perimeter and width. So start by just writing your formula down. I'm going to make my L's like a little cursive just so I can tell the difference between an L and a 1. I'm trying to get the L alone. Right now that L stuck to the 2. I want to do what's happening to the 2 L's, we're adding 2W. I want to do the opposite and subtract 2W on both sides. That gives me P minus 2W equals 2L. I still want to get that L alone. I ask myself what's happening to L. It's being multiplied by 2. The opposite of multiplying by 2 is to divide by 2. So P minus 2W divided by 2 equals L, which is option B. No, yeah, a B. So in the test online, write this on your paper, and in the online test, you'll just click on the B. Raise your hand if you need more time on the screen. Okay, so it was option B. P minus 2W divided by 2. Let's go to number 18. Number 18 says, a projectile is shot into the air. The altitude of the projectile after t seconds is modeled by the function graph. The time, the t, is measured in seconds. The altitude, which they have as h of t because its altitude is your height, that is being measured in feet. So we're looking at our graph. Notice the x-axis from side to side is your time. Vertical is your height in feet. Which of these statements is true? The projectile reaches its maximum altitude of 12 feet. I am going to work this one back in here just so we can see it and I can write, okay? The maximum height of 12 feet. What is the maximum height right here? What's the maximum height of my parabola? It's 19.4, so I know that this is incorrect. The projectile reaches its maximum altitude after 12 seconds in flight. 12 seconds is when it hits that max, so that is the right answer. Make sure you're checking every answer though. Okay, you know how sometimes they'll put those, what is the best answer? I hate those questions. But you do always want to check every answer just to make sure that you're correct. The projectile is launched from the ground. Is this one being launched from the ground?
No.
It's being launched from how high? Very good. Your y-intercept's your beginning of point, so that's not it. The altitude is increasing over the interval from 5 to 20 seconds. So what that's saying is from here to here, all of this, is it increasing? No, because once it hit 12 seconds, it's now decreasing. So in the actual test, we're going to click our answer, which was B, and then arrow to the next question. Now on this, when you've got questions that have a part A, part B, this is giving you the same information, but in a table. If you're more of a visual learner, you're going to want to probably look at that graph to help you answer some of these. And you're very much, it's very easy to just click back and forth. But I am going to explain it.
Part A's and part B's?
There are quite a few, yeah. And part C's and D's. Yeah, it's okay. All right, so this table is basically telling me the same information. So it's starting at 5 feet. After 4 seconds, it's at 13. At 12 seconds, it's reaching its max. Notice that the numbers on either side of that 12 are the same. The reason that is because this has a line of symmetry. This graph is symmetrical, okay? It reaches its max, then starts going back down again. So which statement is true? H of 4 is less than H of 20. That 4 is my input. So I'm looking for here, H of 4 and H of 20. Is 13 less than 13? No. The next one, it really is easier to look at the graph to determine that. The flight is symmetric about the line when its t or time is 10 seconds. Is this the line of symmetry here at 10 seconds? No. When looking at a table, you're looking for where it reaches its max. That's going to be your line of symmetry. Okay? So here is where it's symmetrical. The symmetry is actually at 12 seconds. It says the projectile will hit the ground at some time less than 24. Look at my graph right here. It hits the ground after 24, not less than 24 seconds. Also on the table, you can see that it's still not back at the ground. We'd have to add more to get to the 0. Now, what part D is saying, and I don't want it to confuse you, by process of elimination, we know that D is the right answer, but I want you to understand what this means when it says what it says. It's saying that H of 12 minus a number is the same as H of 12 plus a number. Think about this for a second on these two ones. If I did 12 minus 8, I got 4. Which is this output. If I do 12 plus 8, I get 20, which is this one. And the value of the function is equal at those points. That's what this is saying right here. Is that if I go from my line of symmetry, I go to the left a certain number and to the right the same number, my output value is going to be the same. So make sure you have this written on your paper, and then you're going to go ahead and click the answer on the online test, which was answer D, and then you can arrow over to the next question. So click answer D to the next question. And y'all should have this written. Good job, good job. Okay, try to make sure you write as much as you can. Written. Okay, make sure y'all write as much as you can on this. These are notes that will help you. All right, let's go to the next question. Yes, this is another one I'm going to have to write. Oh, wait, I didn't go back to my test. Let me go back to my test and click that answer real quick. D, arrow over to 19. I'm going to write from the Promethean board so the recording picks it up. But what D is saying, and 19 is saying, a random sample of 200 teenagers participated in a taste test. Each teenager sampled 4 different types of drinks, and they labeled them A, B, C, and D, and were asked to pick their favorite. The table shows the results. So make sure that you're just aware of what this table is saying. They separated how many boys liked each one, and the total number of boys, how many girls like each one, and the total number of girls. They put the total number that liked A, the total number that liked B, C, D, and our total number of students was 200. Okay? It says, based on the information, which statements are true, select all that apply, means we try every answer. The first one says 40% of the participants were girls. So I want to see how many total girls there are, 80, out of how many total participants, 200. I can use my calculator and divide that. 80 divided by 200 gives me 0.40. As a percentage, I'd move that decimal point over. That is, in fact, 40%. So A is correct. Part B, or option B, says 70% of the participants preferred A. The total that preferred A is 70 out of 200. Is that 70%? No, that's actually 35%. So this one is not correct. The next one says 20 out of 120 of the boys preferred D. Here's D. Here's the boys. 20 out of 120, that is correct. Ten out of 35 of the participants who preferred B were girls. So I'm looking at B. There are 10 out of the 35 total were in fact girls. So that was correct. And the last one says the proportion of boys who preferred C is equal to the proportion of girls who preferred C. The boys with C, I have 30 out of 120 boys. Is that the same as the girls, which were 30 out of 80 total girls? Is that the same proportion?
No.
No, definitely not. Make sure you go to your test and click on your correct answers, which were A, C, and D. Then arrow to our next problem. 20. We're gonna go until there's like just a few minutes left before the bell. We're gonna get as much done as we can. All right, number 20 says a local theater sells admission tickets for $9 on Thursday nights. At capacity, the theater holds 100 customers. What's that at capacity mean? That's the most it can hold. So when it's full, it has 100 customers. The function M of n equals 9n represents the amount of money that the theater takes in on Thursday nights, where n is the number of customers. What is the domain of M of n? M of m of n. Domain is my input values. So we're talking about the number of customers. Are all whole numbers possible for the numbers of customers? So in other words, I could have 0 customers, 1, 2, 3. Could I have 1,000,000 customers? No. So all whole numbers, which goes on forever, is not a possible answer. All non-negative rational numbers. A rational number would look like a fraction. Can I have a half of a person? No.
Yeah, they could be in a wheelchair.
If they're still a person, they'd have to pay for a full ticket. All non-negative integers that are multiples of 9. So are they only going to let 9 people in, 18 people in, 27 people in? Or can you go between those numbers? Right. So that means it's not going to be a multiple of 9. So D is automatically going to be our right answer. But what it says is the non-negative integers, which means 0, 1, 2, 3, 4, less than or equal to 100. Since it only holds 100, that's why this is the correct answer.
Mm.
21.
Can you do it? I told you we can make it past 20.
They give us the graphs here for this. The first graph is negative x cubed minus 4, which is this one that goes down. The second one is 0.5x squared plus x plus 4, which is our parabola. It says use the graphs to find the solution of when this equation, when these two graphs are equal. What are we looking for on the graph for when they're equal? The intersection, which is right here. Notice the box says x equals. They only want the x value of that, so we're going to put in -2. Number 22. We're going to go to Desmos for this one. It says which of these points are on the graph. So let's open Desmos and type in the equation.
But it was -2.
It was -2.
Thank you.
-3x plus 6y plus 5 equals -7 is the equation that's given here. What we're going to do is test each point. It says select all that apply, so I must test every point, and I'm just looking to see which ones fall on my graph. -3, 6. That is not on my graph. What about -2, 0? Still not on my graph. Let's try 0, -2. That one is in fact on the graph. So I'm going to select that one. I have to keep going because it says select all. Let's try 6, -3. Not on my graph. And the last one, which is 8, 2. That one is on the graph. So C and E are our correct answers. Make sure you have that on your screen. Make sure you choose the correct answers. Remember to keep these things on your screen. I want everyone entering them in because I don't want you to get to the LEAP test and not know how to work Desmos well. You know what I'm saying? That's why I like for y'all to enter everything in. I want to make sure each person knows how to use Desmos. That's really going to make a huge difference in how you perform. Yeah, this session goes up to number 28. So we've got a little bit ways to go. I know we're not going to finish in this class, but that's fine. Oh. All right, raise your hand if you need more time right
The
here.
last two questions have 3 questions.
Yeah. All right, let's go to question 23. At the beginning of an experiment, the number of bacteria in a colony was counted at the t = 0, when time is 0. So at the beginning means time is 0. Okay? The number of bacteria in the colony t minutes after the initial count is modeled by this function. What is the average rate of change in the number of bacteria for the first 5 minutes of the experiment? Select from the drop-down menus to correctly complete the sentence. So here's what we're going to do with this one. I'm actually going to go in and look at Desmos. I'm going to type this into Desmos. So we've talked about Desmos likes X's and Y's, but when you're using function notation, you can use whatever you want. So I can put B of t equals, I hope I can anyway, 4, open a parenthesis, 2, close it, and raise it to the t power. When it's asking for the average rate of change, they're talking about the slope. And you may want to write yourself a little note under here or just anywhere. Rate of change is slope. So the rate of change problems were lines. The rate of increase were those exponential ones, okay?
Is there a 1?
Is there B of R?
That's B of T. So look, y'all, it's in the problem. I'm just typing the problem, the equation right here. And I'm keeping it in function notation.
You said rate of change slope.
Yeah, rate of change is slope.
So from back here, it looks like.
It's asking about the rate of change for the first 5 seconds. So the first ordered pair it goes through is 0, 4. I'm actually going to put this one, I'm going to split the screen and do this one because I do need to write for this one.
Is Algebra.
Here we go. What?
Do I come back to your class for one time?
For win time. Win time, y'all are going to go to your LEAP classes first, directly from when the bell rings at the end of 7th. Go to your LEAP class.
Oh, first?
Once everybody gets there, the teacher's satisfied, everybody knows where they're supposed to be, then they're going to ring the bell or come on and announce to go back to win time. So you go straight to your LEAP testing place.
I'll go to the bathroom.
Okay. All right, so let's look at this. So the first point I see is 0, 4. I now want to see when the x is 5, what that output is. When x is 5. And we might have to zoom out a little bit. When x is 5, my y is 128. So 0, 4, and 5, 128 are the 2 points that I have. So 0, 4 and 5, 128. Rate of change is talking about the slope. Your slope formula is y2 minus y1 over x2 minus x1. We also say that it's the change in change in y over the change in x. Y'all use those key phrases, rise over run. If it helps you to label your ordered pairs, this will be my x1, my y1, x2, y2. It doesn't really matter which one goes first, just so if I start using, say I want to use the 128, I have to start the x with the 5, okay? So let's do y2, 128, minus y1, 4, over 5 minus 0. That gives me 124 over 5, and I want to try to simplify that, or divide that, actually. 124 divided by 5, whoa,
24.8.
is 24.8. So now the only question we need to figure out is what this rate of change is saying. So when it's talking about the change in y over the change in x, y is representing the number of bacteria, x is representing your time, okay? So the way that it's changing here, let's look at our drop downs. In the first 5 minutes, we said that it was, let me split that because I can't see it very well. 24.8 bacteria per minute. A rate of change is always going to have a per. So it's 24.8 bacteria per minute. Make sure you have that written. Make sure you have it, your Desmos graph. So y'all should have all those notes. Good job, good job. All right. Anyone need more time? All right, let's go to number 24. Okay. I think that one of the most challenging parts about LEAP is making sure that you're reading it all, because this one's a little tricky because it's not talking about from the beginning of time, okay? It says that an elephant population in northwestern Namibia, in Etosha National Park can be predicted using this expression. B is representing the number of years since 1995. So this experiment or this calculation, the counting of the elephants, began in 1995. So the way this table is set up, here is the year. Since 1998 is 3 years past 95, the base year would be 3. And then this table gives us the estimate. It says the elephant population in northwestern Namibia. Oh wait, I read all that. What does the value 2,649 represent? So first of all, do you see where in this equation 2,649 is? Okay. The change is inside those parentheses that's being raised to the exponent. So just like, I don't know if y'all remember how well when we did geometric and arithmetic sequences, but just like for lines, we have y equals mx plus b, the b is the beginning. For an exponential, the constant that doesn't have the variable, this constant here, is your beginning amount. However, you have to make sure that you know when the beginning was. So is this the projected increase in the number of elephants each year? No. Oh wait, X. No. Is this the predicted number of elephants in 1995? When did I begin counting?
1998.
No, I began in 1995. Okay, so that's what this is. This would be my y-intercept to the graph if I graphed it.
Wait, so why did it say it's 2 different things?
Huh?
The graph saying 1998 and then the
But so look, the table says 1998, but that's 3 years since the beginning. Yeah, that's what I'm saying. You have to make sure you're reading carefully. Time began in 1995 for this table. So it is B. That is correct.
What is Namibia?
It's a place.
How do you say it?
Namibia.
Where is that?
I'm not sure. We can look it up later.
Who plays Africa?
All right,
Oh, I know it. I just said that. It's not new.
25.
11:33.
Yeah, we got a couple minutes. We can get 25 done. 25 is an easy one that we're going to put into Desmos. It gives us a quadratic, and then it says to complete the statements and to put your answers in the box, the equation can be rewritten as. So let's go to Desmos. Let's type in this equation that's here, which is negative y equals negative 2x squared plus 4x plus 5. There's my graph, okay? Hopefully you remember vertex form. We did write this on the board earlier, but if you need to write it down again, you can. But vertex form, remember, was when it's the x minus h in parentheses squared plus the k. We talked about how the h value is your x shift, the k is your y shift. So since I see that this vertex right here is at 1, 7, I think I need to be putting that in to these boxes, okay? So I'm going to try to see if I can come up with the equation for this that's the same. It's a negative 2 and then an open parentheses and x plus. That is part of what's written here. So I need to see what goes into this box. This graph shifted to the right. So remember, your base would always be at the y-axis right here. It went to the right 1 unit. So if I did a plus 1, I want to see what that would do. Squared. And then I see that it shifted up to the 7. So I'm going to put a plus 7 here. Did I enter the correct one?
Here.
What I need? No, I actually didn't. This, I should not put a 1 right here. What I should put is a negative 1. So do you see, since this started with a plus inside, what I have to actually type in is negative 1 because it went to the right one. Remember your x values being opposite. So I type in a -1, my y shift was a 7. And I use Desmos, I can see that these are the exact same. I know my answer's right. I don't have to hope it's right. Therefore, the vertex of the function is located at, remember your vertex is at 1, 7. All right, number 26. It says Jerome is constructing a table of values that satisfies the definition of a function. So remember, the definition of a function says that if, why wouldn't you move? I don't know why this won't move. If you have each and every input can only go to one output. So basically your input values cannot repeat. We can't have two input or x values that repeat in order to be a function. So if I'm trying to see which numbers can be placed in this empty cell right here that satisfy the function, I just have to make sure none of the other inputs are that number. So for -5, there are no other x input values that are -5. So -5 would be still satisfying definition of function. -1, I see a -1 right here. Therefore, -1 cannot be an option. 0, there's a 0 here, so it cannot be an input option. 2, there is no other 2, so I can have 2 as an input option. 11, I see 11 right here, so that can't be right. 17 here, so the only correct answers would be A and D. Number 27, Phil and Matt made cookies for a fundraiser at their high school. Phil made 25% more cookies than Matt. The cookies sold for 25 cents each. After the sale, 20% of the combined total of their cookies remained. Part A says to create an equation to represent the total amount of money Matt and Phil earned at the fundraiser based on the total number of cookies that Matt made. Explain how you determined your equation. So first of all, what we don't know that we would need to know to find everything out is Matt's amount of cookies. So I can define a variable saying that my X value is Matt's number of cookies. So I'm going to start right there with that. I'm going to say, let X be the amount of cookies Matt made. Phil made 25% more. So if Matt's percentage, which was 100% of his, Phil's made 100% plus 25% more. So that means as a decimal, Phil made 1.25 times X. 100% plus 25%. So 100% as a decimal is 1, 25% is 0.25. Combine them, Phil made 1.25 times X amount of cookies. Their combined total would be X plus 1.25 X. So now I know their total number of cookies. I'm trying to create an equation to determine the amount of money that they made. So they sold each cookie for 25 cents, but after the sale, 20% of their combined total still remained. So if 20% remained out of the 100%, 80% of the cookies is what they sold. So my equation is going to be 25 cents, 0.25, times 80%, 0.80, times the combined total of X plus 1.25 X. That is the amount of profit, or the amount of money made. Next, If Phil and Matt made a total of $72 selling the cookies, how many cookies did Phil make and how many did Matt make? Show your work. So I'm gonna keep this equation here that I created, right here. I'm just gonna copy it and bring it to this next part. Okay, so they made this much amount of money. Sorry for my typos. They made this much money. In this problem, it's telling us that what they actually made was $72. So I'm gonna set this equation equal to $72 and then solve. So for me to solve this, I'm just gonna use the calculator. I'm gonna multiply 0.25 times 0.8, and I get 0.2. Come down to the next line. 0.2 times, and inside of these parentheses, I'm gonna go ahead and add it. Remember, if there's no coefficient of the x, it's an understood one, so it'll be times 2.25, because I add 1x plus 1.25x, and that is gonna equal my $72. Close my parentheses, equals 72. I can multiply that 0.2 by the 2.25, and that gives me 0.45x equals the 72. I want to divide both sides by 0.45 to get that x alone. So 0.45x divided by 0.45 is going to equal 72 divided by 0.45. I end up getting that x will equal, so let's do 72 divided by 0.45, 160. I have to go back and think about what x is representing. X is representing the amount Matt made. So what that tells me is Matt made 160 cookies and Phil made 1.25, 125% of Phil's cookies, which was 160. And that amount, when I multiply that out, is 200 cookies. So Phil made 200 cookies. So that's my final answer. Matt made 160, Phil made 200. Their combined total was 360 cookies. Part C says, next year, Phil and Matt. Part C, next year, Phil and Matt may sell the cookies for 50 cents each. They plan to make the same total number of cookies, but they predict that they will only sell 70% of them given the price increase. Based on their prediction, should Phil and Matt raise the price of the cookies? Justify your answer. So, last year, or this year, they made a total combined amount of $72. So, this year, they made, first let's say they made 260 cookies and earned $72. So they made that many cookies, let me do this, but only sold 80% of that. So 260 times 80% was 208 cookies. So they sold 208 cookies and made $72. Next year, if they sell 70% of 260 cookies, they will sell, so let me find 70% of 260, they will sell 182 cookies. At 50 cents a piece, they will earn $91. So is this a correct assumption? Number 28, consider the 3 points, -4, -3, 20, 15, and 48, 36. Graph the line that passes through these 3 points on the coordinate plane. Select the line button, click on the location of the coordinate on the coordinate plane that is on your line, and drag to another location on the line. So what we need is 2 points on the line. However, if you look at these points, they're not going to fit on our grid. So what we need to do is find another point that's on this line. And since slope is constant over the line, that's what I'm going to use. So I'm going to try to find the slope of this by doing my slope formula. M is y2 minus y1 over x2 minus x1. I'm going to call this one my x1, my y1, x2, y2. So for this slope, I'm going to do 15 minus a -3. Remember, minusing a negative, what you're going to end up doing is just turning it into a plus, and then ignore this parenthesis at the end. And then for the second one, the x values, it's 20 minus a -4. Again, that's going to turn into a plus. So I have 18 over 24 as my slope. Again, I can't rise and run 18 and 24 just because of the fact that it doesn't fit on this grid. I need to simplify this fraction by dividing both parts by 6. So I get that my slope is actually 3/4. So I would rise 3, run 4. I'm going to go back to our graph, our test tab, and go ahead and graph that line now. All right, so it says to select the line tool, click where we know a point is. -4, -3 is a point. I'm going to hold down the mouse button. I'm going to use my slope now to go to the next point. Rise 3, run 4. So it's going through this origin here. Now, because I want to be sure I'm correct on everything, I'm going to go ahead and graph, not this calculator, my bad, the other one. I'm going to use a graphing tool to create the actual, to see where all these points are. I'm going to go ahead and click this plus sign and add a table. Then I'm going to type in these ordered pairs. Now, when we used Desmos in the past, there was a way to go from a table to a line, but I'm seeing that that's not an option in this, in the test version of Desmos. So, what I'm just going to do is try to check what I did here. Let's see. The point that we ended up going to on this was 0, 0. So what that means is my 0, 0 needs to also fall in that same line. Now there is a really cool button right here. See this one, the zoom symbol, the icon for zoom? Zoom fit is going to make it to where all your points line up, which is perfect because now I can see that that 0, 0 is in fact in line with these. I could even graph the line using the slope we came up with. Y equals 3/4 x, and I can see that it does go through all of these points. Good. Found a place to put this thing that it's not bugging me. All right, let's go to the next question. Use the graph in part A to explain why the ratio of the y coordinate to the x coordinate is the same for any point on the line except the y-intercept. So what they're saying when they're talking about the ratio of y to x, they're talking about our rate of change, our slope, okay? And what we're gonna do is kind of use a version of the slope formula to explain why it's not true for that. So for any point on this line, I can take the the y value, subtract 0 from it, and that is gonna be, you know what, I should put these in parentheses, let me just do that. Y minus 0 over the x minus 0. So I'm looking at the ratio of y to x, so y over x. Now what this means when I type the y minus 0, x minus 0, I can plug in any point and subtract 0 from both only because of the fact that this graph right here is going through the origin 0, 0. So I'm gonna be using one point as different values, and then the 0, 0, 1. Now the reason that it's not going to work for every point except for the y-intercept is my y-intercept, the y-intercept is at, well, x and y is at 0, 0. So if I were to plug that into this formula, I would end up with 0 minus 0 over 0 minus 0. Am I allowed to have a 0 in the denominator of a fraction? No, I am not. So this is not possible for the y-intercept because it is undefined when the denominator becomes 0. So see right here, I would have 0 minus 0, which is 0. That would give me my 0 in a denominator of a fraction, and that's not something that we can do. It makes it undefined. Cannot divide by 0. Part C, let's move to the next part. Part C says, what about the points that lie on this line? Would that also be undefined at the y-intercept? Let's go ahead and check that one first to see what the y-intercept is. Because if we look at it, the y-intercept before was 0, 0. And since you can't subtract 0 from 0 in the denominator, we want to see what the y-intercept is for this line. So I'm just going to go ahead and graph it. Y equals 3x minus 2. When I look at my graph for this, I see that it's not going through 0, 0. In fact, my y-intercept is at 0, negative 2, which means that I would end up getting not end up getting anything undefined. Okay, so let's see how I want to word it. Explain my answer. The y-intercept of this equation is at 0, negative 2. So it does not produce a 0 in the denominator. Let me move this for a second. Let's talk about why not in the denominator. Because, let's say why, we want to explain. Because it does not go through the origin And that is session 2.